assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, so here we have a question about lattice energy. Anytime you have a question with kind of a big word, it's important to take note of that word's definition before beginning. So lattice energy is the energy that's released when ions are combined to make an ionic compound, all right? And the term lattice is just referring to the structure that they take, and that you have kind of alternating cations and anions that arrange themselves in orderly fashion. And so this is known as a lattice, okay? And so essentially, if you have a high lattice energy, that means you have really strong bonds between your cations and anions. So the better the attraction, the better the lattice they make, and the more energy they release when forming the lattice. All right, so let's go ahead and look at our different compounds. So we've got KCl, first of all, versus RbCl. Now, when you're kind of tackling these problems, what you're looking for are two factors. First, you're going to be looking at the charges of the ions, okay? And so essentially, a higher charge is going to mean more attractions, which will give you more lattice energy, okay? You're also, in addition to charges, going to be looking at the size of ions, all right? Now, what you're looking for here is ideally the smaller ions are able to get closer together and therefore create better attractions. So you want high charges and small sizes, better attractions, more lattice energy. All right, so let's look at KCl versus RbCl. So first, let's take a look at charges. And again, you'll want to have your periodic table kind of ready for this. So potassium and rubidium are in group 1 over here. And then chlorine is all the way in group 17 over here. So due to their location, potassium and rubidium will both have a +1 charge, and chlorine will have a -1 charge. So in this case, the charges are going to be the same for both compounds, all right? So we can't really make a decision based off charge, so we must need to look at the size factor. So if we remember from our section on atomic radii, the size or radius of atoms gets larger as you go down the periodic table. So that means rubidium will be a larger atom than potassium. Since potassium is smaller, it will have better interactions with the chlorine, stronger bonds, it'll create a higher lattice energy. All right, so now let's pop on over and let's take a look at part B, which is comparing calcium fluoride versus barium fluoride. All right, we're going to find kind of a similar situation as we did before. So calcium and barium are both in group 2 on the periodic table. They'll have a +2 charge. Fluorine is in the same group as chlorine, so it will have a -1 charge. So if the charges are the same, then we need to go ahead and look at the size of the ions. So just like before, since barium is further down on the periodic table, it will be larger, meaning it will have less attractions than the calcium fluoride. Better attractions, stronger bonds, greater lattice energy. All right, and finally, let me get a new whiteboard, kind of getting crowded there. For part C, we're looking at calcium oxide versus potassium iodide. So again, let's check out where these guys are located on the periodic table. So we have calcium in group 2 over here. We have oxygen in group 16. So we'll have a +2 and a -2 charge respectively. And then we'll also have potassium, which is in group 1 with a +1 charge. And then iodine, which is in group 17. So he will have a -1 charge. So we'll kind of fill those in. All right. So already this compound calcium oxide is kind of winning on the charge level. He has higher charges, which will give those ions better attractions and a higher lattice energy. And also, he has kind of the size factor going for him as well. Calcium, being further to the right of potassium, will be a little bit smaller. And oxygen, being higher than iodine, will also be a little bit smaller as well. So you have smaller atoms, higher charges, stronger bonds, greater lattice.